Hello everyone, my name is Arishwaran. I am going to share a quote said by Michael Jordan. He is an American businessman and an NBA player. He said, I have failed over and over and over again. That's why I succeed. Its meaning, failure is the first step in the process of success.
The switch is closed at t equal to 0. Let us assume that current through this is I of t. We have to find the expression for I of t. In your syllabus only, Laplace domain analysis only. In the previous class, we have seen how to solve by time domain as well as Laplace domain. Both we have seen. Hereafter, we are going to see only Laplace domain. Laplace domain will be easy. First, we have to find the expression for I of t. Find step response. Find step response. Or find the transient response when t equal to 0. Both are correct. It is given that Vc of 0 equal to 0. Initial voltage across the capacitor is 0. Now we have to write KVL. Write KVL for the circuit. What is that? Here we are traveling from minus to plus. We are traveling from A to B, then C, then D. So we are traveling from negative to positive across the voltage source. That's why plus V. A drop across the resistance. We are traveling along current direction. This is the current direction. That's why minus R I of t. Time varies here. Current varies here. Current varies. That's why I within bracket small t. It means it is function of time. As time varies, current varies. That is the meaning. In all transient, if it is varies, we will write I of t. It is function of time. Current is function of time. Minus, what is the voltage across capacitor? 1 by C integral of I of t dt minus infinity to t equal to 0. This is time domain equation. If we take Laplace transform for this, this is constant. This is constant. The voltage of the battery is constant. That's why you can write this as V u of t. If you write V u of t means this function is exist when t is greater than or equal to t. Because at t equal to 0 only we closed. That's why we can write V u of t also you can write. Or simply you can write V. But you should remember that V is constant. Sometimes they will give V of t also. It means what? The applied voltage is a variable with respect to time. Variable with respect to time. If it is given V, if you take Laplace transform V by S, any constant, if you take Laplace transform V by S. If V of t is given, then Laplace transform is V of S. We do not know the function. That's why simply we are putting V of S. If we take Laplace transform, we'll put simply V of S because we do not know the function. Here it is constant. That's why if we take Laplace transform V by S minus R I of t, if we take Laplace transform, we do not know the function. That's why we have to write I of S minus integral of something. Integral of something. Integral means 1 by S. Therefore, I of S, if you take I of t, Laplace transform I of S upon Cs plus within bracket plus V. Already I told you that integral of I of t dt Today only we will write like this. After that, we won't write like that. Minus infinity to 0 minus I of t dt divided by S, CS. Initial charge in the capacitor is 0. That's why this becomes 0. Or this also can be written as, this can also be written as Q of 0 divided by, if you integrate current up to 0, Q of 0, up to 0 we have integrated. That's why Q of 0 divided by CS. Q by C equal to V, that is equal to V of 0 divided by S. V of 0 is 0 given. That's why this becomes 0. So R, you can write like this, V of S minus R I of S minus I of S divided by CS minus V of 0 divided by CS. But V of 0 is 0, it is given. Initial charge in the capacitor is 0. That's why we can say this is equal to 0. So what is the remaining? What is the remaining thing? V of S minus R I of S minus I of S divided by CS equal to 0. If you take I of S outside, you will get R plus 1 by CS equal to V by S. R I of S equal to I of S equal to V upon S multiplied by R plus 1 by CS. Take R outside, R and this S, CS also outside, you will get V divided by S divided by CS. You are taking CS outside, that's why RCS plus 1. I of S equal to R, I of S equal to S getting cancelled, therefore CV divided by RCS plus 1. That's all. This is solution. We found as to find I of t, but we got I of S. So we have to take inverse Laplace transform. Inverse Laplace transform, if you take, you will get, for that, we can write one more step. If you take RC outside, C by RC multiplied by V divided by S plus 1 by RC. C getting cancelled. That is equal to 1 by R multiplied by V by R multiplied by 1 upon S plus 1 by RC. V by R is constant. We know that Laplace inverse of 1 by S plus A equal to e power minus AT. Am I correct or not? We have to remember the formula. Okay. Therefore, here A equal to 1 by RC. Therefore, I of t equal to V by R is constant. For this, if we take Laplace inverse e power minus t by RC. V by R multiplied by e power minus t by RC. That is the expression for I of t. The expression for I of t. In the previous class, we obtained expression for V of t. Vc of t. Now we found the expression for I of t. I of t equal to what? I of t equal to V by R e power minus t by RC. I of t equal to V by R e power minus t by RC. When t equal to 0, what will happen to the expression? When t equal to 0, e power 0 equal to 1. V by R equal to 1. V by R equal to, V equal to, let us assume that R equal to 10 ohm, V equal to 10 volt, you will get 1 ampere, you will get. So V, if you know V and R, we can find the current. That is the maximum current. Initially, current will be maximum. We know that capacitor will be a short circuit initially at T equal to 0 plus. Capacitor is short circuit. That's why only resistance will be there at 0 plus. T equal to 0 plus. That's why current will be V divided by R. Yes, we are getting, if you substitute T equal to 0, we are getting V by R. That's why the expression is correct. When T equal to infinity, what you will get? E power minus infinity equal to 0. That's why current is 0. So final current is 0. Initial current is V by R. That's why when T equal to 0, I of T equal to V by R. When T tends to infinity, I of T equal to I of infinity equal to 0. I of infinity equal to 0. Therefore, the current will vary like this. Initially, it will be V by R. Initially, I of T. Initially, it is V by R. Then it decreases exponentially and goes to 0. Goes to 0. This is I of T. This is the expression for I of T.